right. Today we're going to talk a little bit about solving some particle segmentation and things that you can do to get a proper segmentation. I've thrown the word challenging in because, well, it'll be obvious in a second. So typical issue is particles are not easily segmented or identified. As you can see here, fairly recent sample, two classes of particles. Something fairly bright, sort of like a dull white, gray background, and slightly brighter mid-gray particles. You can even see in here that there's some challenges. That you have dark areas within here, there's some fractures. This is really a whole particle. It's just, the nature of it. And so, the question is, when you have these types of challenges, first one is, how do you properly segment? You can see the obvious here. If I just try to do intensity threshold in your segmentation, there's that combination where you have green inside blue, you have a predominantly homogeneous particle here, you still have blue in there. If you try to count this, you're going to have mixing and matching of the different phases or different classes within each particle. Taking the next step, the other challenge is, if you use smart segmentation, which is machine learning, you can still run into these same problems where you can have this mix of classes in here. And this is just actually a recent problem that came up where they were trying to classify into both how many particles, what class do they belong to. And so how do we end up here? So, and we'll go through a live demonstration. But instead of trying to use segmentation, regardless of which methodology, whether it's smart segmentation, machine learning, or intensity-based segmentation, is to find everything first. That makes it a lot easier. There's a number of examples. We've gone through some of these in the past, and this is just another example of it's easier to find everything first, separate the particles from the background, and then we can actually classify them. So in this case, using smart segmentation, find all the particles first, optimize the parameters because we don't want to calculate a series of or a number of unnecessary parameters. Set your options as standard count size. Fill holes if you need to in here. In this case, there's a number of good examples because there's tiny little, what appear to be holes, but some dark areas, some of it, some shading issues. Fill holes as required. Set the measurement type ranges so you can gate out or filter out things you don't want to measure. If you want to have clean borders, set those. And object splitting as required. And as always, because we're going to use learning classification, which is another version of machine learning, we're going to train ImagePro to classify these particles once we've segmented them. And the key to learning classification is to what measurement types or parameters are going to be necessary to do a statistical analysis to separate our particles into the correct classes. And typically, matter of fact, let me not even say typically, it's required that when you do your count size operation to set your counting and identifying your particles, to always include measurement types that are going to be appropriate to use in learning classification. So if you're using something with color, whether it's, even if it's a chemistry or could be dye, something like that. Oops, sorry, I guess I'm a little low. If, using dyes or anything like that, is to include measurement types or parameters that are going to be color-based. So the intensity of the color channels, integrate optical density, things like that. There's a couple of other color channels available in I think LAB is in there, YIQ, to really use those parameters that you have available to do the right classification. In this case, we're looking at grayscale particles. So things like mean intensity, maybe standard deviation, integrated optical density, clumpiness, heterogeneity, which are textures if that's appropriate. And we'll use these parameters to do the classification. And as always, if you're going to be doing more than a one-off, then you're going to be doing the same analysis over and over again, or you're going to put it into a standard protocol where you're running a macro doing this. save your count size, and learn classification settings, because then you can reuse those and apply those over and over again. All right. Excuse me. Time for a little demonstration. Perfect example. Here we can see our particles. You can see these little cracks. Really, this is considered for their analysis, this would be considered a whole particle. Made a little bit of judgment call. You can see some are fairly homogeneous, some have a lot of surface texture, sort of fractures, but the question is, and what we're trying to answer is, how many particles are there? What class are they in doing that distribution analysis? So as always, especially if I'm going to use machine learning, I want to start with the smaller section. Work out the conditions and then apply those to larger images to verify if they're correct. And then again, you can update it. So in this case, I'm going to do a deliberate misselection right up front, just as a reminder. So in count size, what do we want to do? I want to select Smart Segmentation. I want to start from the beginning, clear everything, reset it. Make sure I don't have anything else from a previous analysis there. Measurement parameters. What measurement parameters do I want? So these are the standard ones. I'm going to get rid of some of these because I don't need those. Points, lengths, angle. I usually have area there, especially if you want to classify them in some other fashion. In this case, what are the parameters that would be good for this? Size, maybe not so much, but let's go with the intensity-based ones. Let's see. How about mean intensity? You could use max, min, standard deviation, texture measurements, margination, heterogeneity, and clumpiness. Now, how did I determine those? Oops, let me grab clumpiness here. So how do I determine what parameters I want to use? In this case, I know my particles are around 150 gray levels. Some a little darker. We have these little gaps here and everything else. My brighter particles, 2A. So I know I have an intensity separation, typically mean intensity. These are fairly homogeneous. These have a lot more texture. Might be a little bit iffy, but we'll see how all that works out. But again, I'm looking for parameters that help me separate these monochrome particles, these grayscale levels, into different categories. And it's obvious that these are a bunch brighter, for the most part, than these. Going to segmentation. As I mentioned, we segment everything first. So we go in. I want to take one mid-gray levels, and we'll take a bright one too, just for, probably don't have to because we should pick that up automatically. And I'll select the background. So I'm going to do a misselection here. You can see because I've included, I'm going to zoom up here, some areas that really statistically are hard to separate out. This little, some broken particles here from these edges. And so again, this always goes back to in machine learning, you want to be very selective in what you're choosing. So in this case, I'm going to take my sample. That's pretty good. And when I take my background now, I'm just going to select right about there. Now you can see how much cleaner that is. We can do a little cleanup, but now I've really selected my particles, and they're pretty clean. We'll just do a little cleanup here. And you don't need to reselect areas I already selected. Not bad. I found my particles. Let's clean up the edges a little bit. Again, you'll notice you always want to tend to use something that's inclusive and representative of what you're measuring. Again, I have circles, squares, polygons, and typically that's what you want to use first. After that, for the cleanup, then maybe I'll want to use some lines. But you always want to get something that's representative when you're doing this. So let me just clean this up. I could use a polygon. That's fine. But now you can see how that's really cleaned that up. Remember, if you're doing it too often, too many samples, stop, backtrack, and remove the ones that really aren't adding to segmentation. There we go. There's a good stopping point. Now, as I mentioned, there's some holes, some gaps in there, so we want to make sure we fill those. Let's go to options. So I'm selecting options for my measurement group. I'm going to fill holes. Turn that off. Let's check our ranges. Not too bad. Maybe clean up a little bit of the background. So I'm going to take, again, this is why I always include an area measurement. I'm going to hit the log, and I'm just going to select the minimum, bring that up a little bit to get rid of some of these small areas. Yeah, that's better, maybe a little bit more. Let's see how we're doing there. There we go. All right. I always have apply on close. You can tell there's always some small pixels there, so I got rid of all those. And let's count. Pretty good. You can argue if this is really a particle or not. I can move, yeah, can always come back. And remember, I can always come back and do two things. Here, I didn't have split on. And let's gate out. Sorry. Let's bring this up just a tad bit to get rid of some of those other smaller particles. Yeah, it's going to be a little close there. I can probably segment it or filter this out with some other parameters. Let's just recount that. It might be a little splitting issue. I'm going to leave that off. All right. So now what do we want to do? Typically at this point, I've now counted my sample. I've found everything appropriately. Now I want to classify them. And again, this is where, remember, as I've said, save your settings. Measurement options file. I've already done this before. But save your settings, because then you can use those over and over again once you have the conditions worked out. Learning classification. Now I want to classify my particles. And this is why it's important to have those measurement parameters there right up front. So when you set up count size, have your parameters there. And so now I'll go and add a class. I'll call it phase 1. And I'll go and select and something appropriate. It's telling me what to do here, so I'm going to hold the control key down. Add my second phase. Again, I can change the colors. I'm going to name them. Okay, now I'm going to add all these parameters because I'm not sure at this point which ones are the appropriate ones. We'll calculate. You can see area doesn't make much of a difference, but you're looking for the highly weighted ones. Not surprisingly, mean intensity. Other highly weighted ones, standard deviation, where you gain that statistically we're separating our phase 1 particles from our phase 2 particles from the background. Something heterogeneity, there may be some differences, so let's see how we're doing here. Okay, going through, and you can tell right now, just visually looking, I've properly separated my bright particles from my mid-gray particles. So now I can go on, and remember, if I want to use this again, save your settings, because then you can always recall this and then use it over and over again. From here, I can, send all this data to either, the normal measurements table or to data collector, whatever you need to do in that, or use it in a macro and do a batch process if you have a lot of samples to process.